Why does water always break down into hydrogen and oxygen in exactly the same mass ratio, no matter where the water comes from, a river, a bore well, or the ocean? The answer goes all the way back to atoms, how mass behaves when they rearrange, and how they actually bond together to build every compound around you. The law of conservation of mass, given by Lavoisier, says the total mass of reactants always equals the total mass of products in a chemical reaction. Mass is never created or destroyed. If 4 grams of calcium carbonate reacts with 2.92 grams of hydrochloric acid, the products, carbon dioxide, water, and calcium chloride, add up to exactly 6.92 grams, too. If a reaction happens in an open container and a gas escapes, the mass only appears to drop. It didn't vanish, it just left the container unmeasured. The law of constant proportions, given by Proust, says a compound always has its elements in the same fixed mass ratio, whatever the source. Water is always hydrogen and oxygen in a 1:8 ratio by mass. Dalton's atomic theory explains both laws at once, with one simple idea. Atoms are indivisible, and in a chemical reaction they are never created or destroyed, only rearranged. Some atoms need only 1 or 2 more electrons to feel stable, so instead of fully gaining or losing electrons, they share a pair with another atom. This shared pair is a covalent bond. Hydrogen has 1 valence electron and needs just 1 more, so 2 hydrogen atoms share 1 electron each to form H2, a single bond. Oxygen has 6 valence electrons and needs 2 more, so 2 oxygen atoms share 2 electrons each to form O2, a double bond. A molecule is simply an electrically neutral group of atoms held together like this, able to exist on its own. When we name these compounds, prefixes like mono, di, tri, and tetra show how many atoms of each element are present, but mono is always skipped for the first element, and hydrogen never takes a prefix at all, which is why H2S is simply hydrogen sulfide, not dihydrogen sulfide. Other atoms don't share. They fully transfer electrons. An atom with fewer than 4 valence electrons tends to lose them and become a positive ion, called a cation. An atom with more than 4 tends to gain electrons and become a negative ion, called an anion. Sodium has 1 valence electron. It loses it to become Na+. Chlorine has 7 valence electrons. It gains 1 to become Cl-. Because opposite charges attract, Na+ and Kl- pull together to form sodium chloride, this electrostatic attraction is the ionic bond. Unlike covalent compounds, ionic compounds don't form single separate molecules. They build repeating 3D crystal lattices, which is exactly why they have such high melting points, and why they only conduct electricity when dissolved in water or melted, never as a solid, since the ions are otherwise locked in place. To write an ionic formula, crisscross the numeric charges. Aluminium is 3+ and oxygen is 2-, so aluminium gets subscript 2 and oxygen gets subscript 3, giving Al2O3, and the charges themselves are always dropped once the formula is written. Once you know how atoms bond, you can weigh the result. Molecular mass for covalent compounds and formula unit mass for ionic compounds that don't form true molecules are calculated exactly the same way. Just add up the atomic masses of every atom in the formula. Take carbon dioxide, CO2, with carbon at 12U and oxygen at 16U. That's 1 carbon plus 2 oxygens, so 12 plus 16 times 2, which is 12 plus 32, equals 44U. For a formula with brackets, like calcium nitrate, say A, NO3+, multiply everything inside the bracket by the subscript outside it first. Nitrogen plus 3 oxygens is 14 plus 48, which is 62, then double it for the outer 2, giving 124. Add calcium's 40U, and the formula unit mass is 164U. Forgetting to multiply the whole bracketed group by the outer subscript is the single most common mistake here, so always expand the bracket fully before you add. Quick check. The question's on screen. Pause if you like, but try it first. 10 seconds, go. Find the molecular mass of carbon dioxide, CO2, with carbon at 12U and oxygen at 16U. CO2 has one carbon atom and two oxygen atoms, so the mass is 12 plus 16 times 2. That's 12 plus 32, which equals 44U. The answer is 44U. Mass is always conserved, and compounds always keep the same fixed mass ratio. Dalton explained both with atoms that only rearrange, never vanish. Atoms then bond by sharing electrons in covalent bonds or transferring electrons in ionic bonds, and either way, molecular mass or formula unit mass is just the sum of every atomic mass in the formula. Free notes in the description. Subscribe to Clarix for the rest of Class 9 Chemistry.